Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Set of Skittles by Not Very Neat, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Digits separated by a black dot are in a 1:2 ratio, and not all dots are necessarily given. So, for example, if we had, say, a 2 here, this would have to be 1 or 4 to maintain a 1:2 ratio, because there's a black dot between them. And we have this new rule set, which is called Skittles, where each pair of digits separated by a skittle of the same color sums to the same total, which is to be deduced. And each color of skittle has a different total. So all the cells that are separated by the green A must sum to the same total. And that total must be different than all the Skittles that sum to B. Right? The ones that are separated by a yellow B must be summing to a different total than the ones that are next to an A. Or separated by an A, so I should say. Same with D. D is different going to be from what the sum of A and B are. Same with C. The red C and the purple Ds. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Here, okay, so here we have 4 Ds, which are in the same box. 4 sets of Ds. That means D must be equal to the sum 4 times D, the sum of D. So we're gonna shorthand it. A is gonna stand for the sum of the 2 digits surrounding A. B is going to be the stand for the 2 digits surrounding B, the sum of that digit, C, etc., etc. So we have A, B, C, and D. 4 times D must be equal to 45 minus a digit. And so that means in D we know has to be an integer. So it's going to be 4 times, so it could be either 36, 4 times 9 is 45 minus 9. It could be 40, so D could be 10. So D is either 9, 10, or 11. Because 4 times 9 is 36, which is equal to 45 minus 9. 4 times 10 is 40, which is equal to 45 minus 5. And 4 times 11 is 44, which is 45 minus 1. Okay. So this digit has to be guaranteed to be 1, 5, or 9. Interesting. So that's the information we have from this. A. So we know, okay, we have A, B in row 3. We have A, B, and C all in row 3. And we have a 1:2 ratio. So we know A plus B plus C plus a 1:2 ratio plus a single digit is equal to 45. But we don't know what that is. What other combinations do we have? We have two A's possible in the same box. So it has to be, A has to be great 5 or greater, because it can't be, it has to have 4 digits that add up to that sum that are distinctly different. So it's from 5 to 15 for A. C also has the same restriction. You can have 4 digits in the same box. So B and C, sorry, A and C both are anywhere from 5 to 15. D has to be 9, 10, or 11. And B, we don't really know what the restriction is. We know A, B, and C plus 3 unique digits, 1 in a 1 to 2 ratio, add up to 45. So A, B, and C have to add up to, at most, 39. Right? 3 unique digits, 1, 2, and so 3 unique digits, 1, 2, and 3 could be the minimum, could be there. And 45 minus 3 is 30, minus 1, 2, and 3 is 39. It could also be, okay, it cannot be 7, 8, 9 because 1 is not in a 1 to 2 ratio with the other. It could be 4, 8, and 9. So 45 minus 4, 8, and 9, that's 12. And plus 9 is 21. So 45 minus 21 is 24. So the sum of A, B, and C is as low as 24 and as high as 39. Oh. We have in column 3, A, B, So we have, so D must equal the same as 2 digits in a 1 to 2 ratio, because we have in column 3 A, B, C, and D plus this digit here adds up to 45. Well, we have A, B, and C here, so we subtract that out. That also adds up to 45, so these are the same sum. We can subtract out A, B, C, and this digit, so therefore D must equal 2 digits in a 1 to 2 ratio. Which means D has to be able to be in a 1 to 2 ratio. That's only 3 and 6. So you have 1, 2, that adds up to 3, that's too small. 2, 4 adds up to 6 times 4 is 24, that's too small. 3 and 6 add up to 9, which could work. 4 and 8 adds up to 12, which is too big. 4 times 12 is 48. So this must add up to, so this has to add up to 9, and it's 3 and 6 then, in a 1 to 2 ratio. D must then be 4 times 6, 4 times 9 is 36, which leaves this as a 9. So we have a guaranteed 9 here. This is 3, 6, because D we know adds up to 9, and these are the same pair. So these add up to 9. So we have A, B, and C then. So 45 minus 9 is 36. So A, B, and C. This obviously cannot be 3 and 6. So it has to be 1, 2, 4, 5, 7, 8, 9. 45 minus 10. So it's from anywhere from 35 is the lowest. Or sorry, is the highest sum for A, B, and C. So now it's down to 35 for the highest sum. And then you could have 3, 6, and 9, 18. So 45 minus 18, 27. So it's 27 to 35 is a sum of A, B, and C. Okay. A has to be at least 10, because we have 9 and 1 here, possibly. C is at least 10. Oh, interesting. C is at least 10. A is at least 10. So that's 20. Actually, it has to be 10 and a. Oh, okay. So we know D adds up to 9. A and C, one of them could be 10, one of them could be 11. So that's 21 potentially. Okay. A cannot be 1, and it could not be 9 plus 8 because we have 4 digits that add up to it. C cannot be 9 plus 8. Can't be 9 plus 7. So these are 1 through 6 here. This is 1 through 6 here. This cannot be 9. So these two digits add up to A. These two digits add up to C. A, therefore, must be smaller than C, because if A were bigger than C, the problem is there's no other digit that's larger than 9. And C adds up to this digit plus 9, and therefore this must be smaller necessarily. So A has to be 1 through 5, and here that must be 9 through with 2 through 6. So what are the extents that we can have here? So this is 1 through 5, which makes this 4 through 8 there. This is 2 through 6, so this must be 7 through 3 here. Not there. 7 through 3 here. So add up to 9. C, though, cannot add up to... It has a 3 or 6 here. Oh, it has to be 3 plus 9 at most. It can't be. If we have 3 and 9... If C adds up to 12, we have 3 and 9, that would have to be 6 and 6 here to add up to 12, which doesn't work. So it has to be 3 and 8, because we know C is greater than A. So this has to be 3 and 8 and 6 and 5 here to add up to 11. So C adds up to 11. So that means it's 9 and 2. And A must be at least 10 because it's 9 and something. So it has to be 10 exactly. So it's 2 and 8. This is 9 and 1. So this is 8. That's 7 to add up to 9. 8 eliminates 8 here. This is 5 and 6, which makes this 3 and 8 there to add up to 11. A adds up to 10. This cannot have 1 and 9 here because of the 1-9 pair here. It can't be 2, 8. So this is 3, 7. Or 4, 6. 7 can't be here because of 7 in the row, so this can't be 3. This adds up to 11. No 3, 8. No 5, 6. So this is 2, 9 or 4, 7 here. No 7 here means no 4 here. These add up to 10 for the A's. So this is 10. Cannot be 3, 7. Cannot be 4, 6. So this is 1, 9 or 2, 8 there. So this cannot be a 2-9 pair here, because that would eliminate all possibilities for this 10 sum here. So this has to be then 4 and 7. So we have 4 and 7 here. That means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means no 4 or 7 here. 4 and 7 here means B cannot sum up to 9, 10, or 11. And we have a 1 with it. So what can it sum up to? No 1 and 4 cannot be 1 and 3 because of the 3 in row already in row 3. So no 1, 4 can be 1, 5, 1, 6. No 7, no 8. So B adds up to either 6 or 7. If it's 6, it has to be 1, 5 here, which makes this 2, 8. And that would force this to add up to 2 and 4. So that would be 8. This would have to be 9. If it's 1 and 6 here, that adds up to 7. So no 1, 6. It would have to be 2 and 5 here, which would force this to be 1 and 6 there. That's 1 and 9 here, because 8 and 9 are... So this has to be an 8 and 9 pair there. Interesting. Okay. This is in a 1 to 2 ratio. It cannot have 3 and 6 be there, because that would eliminate all possibilities for this sum for A here. This also has to be 3, 4, 5, 3, 4, 5, and 6. No 3 here, which means this can't be 6. No 4 here, which means this can't be 5. So we're guaranteed a 5 here to add up to 6 or 7. This can't be 3, 6 pairs, adding up in a 1 to 2 ratio, because that would eliminate all possibilities for this pair here, adding up to 10. So it's 1, 2, 4, or 8 here as possibilities. C again adds up to 11. So this digit must be 2 greater than this, because D adds up to 9, and this digit is the same. So this digit is 2 smaller than this digit here. We cannot have 1, 8, or 9, so this is 2, 3, 4, 5, 6, 7. This digit is 2 smaller than that, or 2 larger than that. So 2 greater than 2 is 4, so we have 4 through 9 here. This can't be 5, so this can't be 3. A and B. Remaining digits of column 7. We have 1, 4, 5, 6, 7 as possibilities. 4 and 7 cannot be here because of 4, 7 in the box. 5 can't be here because of 5 in the row. So 7 is guaranteed to be here, which means this cannot be 3 and 7. So we are left with 1, 9, adding up to 10, 2, 8, or 4, 6. Well, this can't be 1 or 4 here, so this can't be 6 or 9 correspondingly. 8 can't be here, which means 2 cannot be here correspondingly. Um... 8 has to be one of these 2 digits, which means 2 has to be one of these 2 digits. Because 8 can't be here, because that adds up to 9, and that can't be the same sum as any of these. B must add up to 6 or 7. So here we have 1 through 6 as a possibility, no 5. D to add up to 9 with 2 or 7, so it must be 2, 7, 3 with 6, or 4 and 5. This cannot be 5 and 6, that would eliminate all possibilities for this cell here. So this can't be 5, this can't be 6, which means 5 cannot be 4 there. Okay. These 2 digits add up to 10, and they cannot have 8 and 9 with it. So it's either 3, 7, or 4, 6 there. This 4, 6 eliminates 4, 6, would eliminate all possibilities for this cell here. So this cannot be 4 and 6, it's 3 and 7 here. That eliminates 3 and 7 in the rest of the column. So to add up to 9, there's not 2, 7, it's not 3, 6, it's 4 and 5. So we have 4 here, 5 here. This must be then 4 and 7 to add up to 11. So we don't have 3, 4, or 5 here. And what does B add up to? It cannot add up to 6 anymore, so therefore it must add up to 7. So this is 1 and 6, which makes this 2 and 5. That leaves this as 1 and 9, so that's 1 and 6 there. 9 eliminates 9 here, so that's 8. This is a 2-9 pair for C to add up to 11. This can't be 2 because of 2 in the row, so that's 9 and 2 there. 7 eliminates 7 here. This is 1 and 6 to add up to 7 here for the B. So this is 2 and 5 as a pair. 4 eliminates 4 from being here. 8 can't be here then, correspondingly. 6 eliminates 6 in the rest of box 6. So this is an 8-9 pair, which must add up with 1 and 2 to add up to 10. That means 1 is eliminated in the rest of the box and column, where we have a 4, 5, 6, 7 quadruplet. In column, also 6 eliminates 6 here. So we have a 6, 4, 5, 7 triplet in column 7, which eliminates 4, 5, 7 in the rest of the column. This can't be 4, it's 6 and 3 adding up to 9. This can't be 5 or 6, it's 1. So this must be a 4, 5 pair here. This adds up to 11 here with no 7 available, no 8 available. 2 cannot be either of these. So it cannot be 2, 9, 3, 8, or 4, 7. It's 5 and 6. This can't be 6 because of 6 in the row. So this is 5, which makes that 6. That means this cannot be a 4, 6 pair. It's 3 and 7 to add up to 10. 5 eliminates 5 here, so it's 4 and 5. Remaining digit in box 6 is a 3. 5 eliminates 5 here, so that's 2 and 5 there. This adds up to 11 without 2, without 5. So this is either 3, 3, 8 or 4, 7. So no 2, 9, no 5, 6. No 3 or 7 here, so this can't be 3 or 7 here. Sorry, this is 3 or can't be 3 or 7 here, so that means it can't be 4, 8 there. And I think the rest is just normal Sudoku. Remaining digits in box 1, we have 2, 4, and 5. We have a 3, 7 pair here. Remaining digits of row 8, we have 1 and 4 remaining. This can't be 1 because of 1 in the column. So that's 4, which makes that 1 there. That eliminates 4 being there. 4 eliminates 4 here, so that's 5, which means this can't be 5 there. Okay. Remaining digits of column 8, we have 2 and 5 available. That eliminates, we have a 2, 5 pair in row 1, which eliminates 2 and 5 in the rest of the row, so no 2 or 5 here, it's 4. That eliminates 4 here. We have, that 4 eliminates 4 here, so this is 8 and 3, adding up to 11. 8 eliminates 8 here. I guess we might not have normal Sudoku here. Remaining digits of column 9. We have 6 and 9. 6 can't be here because of 6 in the row, so this is 9, which makes that 6. 3 eliminates 3 here, so it's 7 and 3. Remaining digit in row 1 is a 9. Remaining digits in row 2 have to be 1, 4, and 7. 7 cannot be either of these digits because of 7 in the column, so 7 is there, which means we have a 1, 4 pair in row 2. Well, we now have a 1, 2, 4 triplet in column 5, which eliminates 1, 2, 4 in the rest of the column. So now we have just 6 and 9 remaining in column 5. This can't be 6 because of 6 in the box, so that's 9, which makes that 6. 6 eliminates 6 here, so it's 1 and 6. Oh, I guess we have these to add up to 10, right? 1 eliminates 1 here, so that's 2 and 8 adding up to 10, which makes that 1 and 9. 1 eliminates 1 from being there. Okay. So that was that. Okay. Where is 1 in row 9? Cannot be here because 1 in the box. These are filled out, so 1 has to be here. Which means where's the 1? We should have 8 ones. No, we don't. Where's the 1 in row 6? Cannot be here because 1 in the box. These are filled out. Can't be here because 1 in the column, so 1 has to be there, which is in a 1 to 2 ratio with 2. Or also 1 eliminates 1 here, so that's 4 and 1, which would have eliminated 4 there, so that's 2. So we have all the 1s now. 2s, we... In row 7, 2 can't be here because 2 in the box, can't be here because 2 in the column, so 2 is there. That leaves that as 4. Remaining digits in row 7 have to be 3 and 6. This can't be 6 because of 6 in the column, so that's 3 and 6 there. We don't have enough differentiators for 2. For 3, we don't have enough differentiators to disambiguate. 4. In column 6, 4 can't be here because of 4 in the row, so 4 is there, which makes this 7, which makes that 4. So that's all the 4s left. 5s, we don't have enough disambiguators. 6s, we have all the 6s. 7, we don't have enough disambiguators. 8, where's 8 in the central box? Cannot be here because of 8 in the row. Can't be here because of 8 in the column. So 8 is there. We don't have enough disambiguators. 9. 9 in box 5 cannot be here because of 9 in the column, so that's 9 there. We have 8 9s. We know where the last 9 is. It's there. 2, still no disambiguators. 3 has to be there. That gives us 8 3, so we know where the last 3 has to be. It's there. 4's done. 5 in row 5. 5 has to be here, which makes this not 5. That's 2 with 5 there. 2 eliminates 2 here, so it's 5 and 2 there. That gives us all the 5s. 6s we already have. 7, we don't have a disambiguator. 8, we don't have disambiguator. 9, our 9 is done. So then we have 2 left again. We have 8 2s. The last 2 has to be there. Now we have a disambiguator. 7 has... Oh, maybe we had them. 7 had to be here, which makes this 8, which makes that 7, which makes that 8. Guess we already had that. Never mind. We had the disambiguator. We just didn't see it. Yep. Anyways, that's the solution. Fairly straightforward, I feel. There are certain things that were very restrictive, right? So I guess the key to the break-in was column 3 and row 3, right? And seeing that they had to add up to the same sum, with everything being the same except for D and the black crop key dot. And of course, that broke everything. That was the breakout, or break-in, for the puzzle, and then everything flowed from there. I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.